Imagine this. You're standing inside one of the most advanced factories in the world, a place where machines operate with such precision that they etch patterns smaller than a virus onto silicon wafers. These are the factories where the future is built. And right in the middle of this technological battlefield is one company, ASML, a Dutch firm that produces the world's most advanced lithography machines. These machines are the crown jewels of the semiconductor industry. Without them, you cannot make the chips that power your phone, your laptop, your car, even supercomputers and AI models. But here's the twist. For years, engineers at ASML believed that even if they handed China the complete blueprints of their machines, China still couldn't build them. The technology was just too complex, too interconnected, and too dependent on global supply chains. Yet today, that certainty is starting to crack. The high stakes of lithography semiconductors are the backbone of modern civilization, and the single most important tool in making them is the lithography machine. Think of it as a projector that shines light onto a silicon wafer, carving out the microscopic circuits that make chips work. At the cutting edge are EUV lithography machines, extreme ultraviolet. These use light with wavelengths so tiny, just 13.5 nanometers, that they can etch features thousands of times smaller than a human hair. The catch? Only one company in the world can make them at scale, ASML. But ASML doesn't build everything alone. Its light sources come from American suppliers. Its high-precision lenses are made in Japan. Its components come from across Germany and the wider EU. Each part is priceless, and assembling them into a working system is like orchestrating a symphony of global engineering. That monopoly gave ASML incredible power. For years, it enjoyed nearly 100% of the global market share in EUV machines, each unit selling for more than $150 million. But politics has now entered the picture, and the global chip war has changed everything. The U.S. control and ASML's dilemma. In recent years, the U.S. government introduced sweeping export controls, essentially blocking ASML from selling its most advanced tools to China. Washington feared that if China gained access to EUV machines, it would accelerate its push towards semiconductor dominance, something the U.S. wants to avoid at all costs. At first, this strategy seemed clever. Deny China access to the tools and they'd be stuck years behind. But there was an unintended consequence. ASML still needed revenue. Its newest generation of EUV tools wasn't selling as well as expected to big customers like TSMC. And as demand cooled, ASML leaned heavily on sales of older DUV lithography machines, especially to China. In fact, for 2 years, ASML shipped as many as it could to the mainland until Washington again stepped in, banning even those sales. Now ASML finds itself squeezed. Demand is sluggish, the Chinese market is closing, and global competitors are starting to emerge in unexpected ways. So what did China do in response? Instead of giving up, Chinese companies began exploring alternative routes to high-end lithography. And surprisingly, they're making progress. Nanoimprint lithography. The first breakthrough came in nanoimprint lithography. Imagine using a mold to directly stamp circuits onto a chip, instead of projecting them with light. It's a completely different approach, and a Japanese company, Canon, has long been the leader here. Canon's most advanced system can achieve a 14-nanometer process, roughly equivalent to a 5-nanometer chip made using traditional EUV methods. Impressive, but still niche. But recently, a Chinese company, Pulin Technology, unveiled something even more ambitious. Their new PLSR nanoimprint lithography system can achieve line widths of less than 10 nanometers. And unlike many lab-only prototypes, this machine has already been delivered to a domestic customer for real-world production. If Pulin can resolve yield challenges during mass manufacturing, China may have its first truly competitive, homegrown lithography tool. Still, China isn't abandoning EUV altogether. One of the most fascinating developments is happening at the Harbin Institute of Technology. Back in 2022, the Chinese Academy of Sciences launched a national program to develop high-end lithography. Harbin's team took on the most difficult part of the machine, the light source. Traditionally, companies like Cymer in the U.S. use laser-produced plasma LPP sources. They're powerful but incredibly complex, bulky, and energy-hungry. Harbin's team, however, chose a different approach. Discharge plasma sources, DPP. By 2023, they had built a working prototype, and by mid-2024, it had passed key performance tests. While details are scarce, insiders say this method is more efficient, requires less power, and could dramatically shrink the footprint of future EUV machines. If successful, it would mean China could eventually build EUV machines that are not just competitive with ASMLs, but potentially cheaper and more energy efficient. The bigger picture. So what does all this mean? First, it highlights a paradox in U.S. policy. By cutting off access to ASML's tools, Washington hoped to freeze China in place. But instead, it gave China the motivation to pour resources into domestic innovation. Second, it puts ASML in an awkward position. On one hand, it has a monopoly on EUV and still dominates today. On the other, Chinese breakthroughs threaten to erode that dominance in the long term, especially if alternative technologies like nanoimprint or discharge plasma sources mature. Third, it shows how fragile global supply chains really are. For years, the semiconductor world was built on interdependence. Japan made the lenses, Germany made the optics, the US made the light sources, and ASML put it all together. But now, with geopolitics tearing at those links, every major power is scrambling to go it alone. The future of the chip war. And that brings us back to the original question. What happens when a country that was once locked out of the most advanced tools starts building its own? If Chinese lithography machines can reach mass production, the balance of power in the global chip industry will shift dramatically. ASML's monopoly would end, the US's control over semiconductor choke points would weaken, and the alliances built around shared interests could fracture. For now, China's new machines still face big hurdles. Yields, efficiency, and scaling all remain major challenges. But the momentum is clear. Step by step, China is closing the gap. Maybe that ASML engineer was right years ago. Blueprints alone weren't enough. But what he didn't anticipate was that once pushed into a corner, China wouldn't stop at copying. It would invent its own paths forward. And in the semiconductor industry, that changes everything. So what do you think? Are we witnessing the beginning of the end of ASML's monopoly? Or just another chapter in a long game where the Dutch giant will always stay one step ahead? Drop your thoughts in the comments. And if you found this breakdown insightful, make sure to subscribe to Fantastic Vision for more deep dives into the technologies shaping our world.